Hello everybody, I hope you've all had a good week. This is the next one in the batch of laptops that I got. So you know the deal guys, no screen, no power adapter, and probably no battery when I take it open as well. But this is described as having a motherboard fault. Now, I know you're probably saying, why is he still bothering with these old laptops that have no screens and no power adapters? Unfortunately, that's all I got for the moment, guys. I've two more coming in that are legit ones coming in for repair, but it looks like a lot of these came from a shop and I think they didn't want to get involved in them because there's no easy fixes among these. But look, I'm going to use them as material for the channel anyway. This is an Asus A540S. I'm going to take the motherboard out of it, have a look at it, and see if we can get it back running again.
I've taken out the motherboard and this is what it looked like after I scanned it in. I found a little trick in Photoshop for improving the quality of it, so hopefully that should improve the quality of my videos going forward. But we're just going to have a cursory look over it here. It looks pretty clean. As you can see, the detail is quite good on this image, but I'm not seeing anything that is cause for worry here. Of course, as usual, if you spot anything, please put it in the comments below. Okay, so I'm not seeing any signs of physical damage. So what we're going to do first is look at the input section. Now, our DC input jack is right down here at the bottom. And as we can see, there is a similar configuration here as to what we've seen on the other videos before. So let me just draw out the path here, right? So our ground is the outside of the jack here, and our center pin is where our positive comes in. So if we mark that in, we have our positive comes up to these two inductors. It goes through those two inductors onto the first MOSFET. That MOSFET has 4 drain pins on this side, 3 source pins and a gate pin. The gate pin controls whether our 19 volts comes through from drain to source. When it does and it switches on, our 19 volts comes then through our first MOSFET and onto our second MOSFET. Our second MOSFET is a similar configuration, except it's turned around either way. So we've got 3 source pins here, our gate pin which controls whether that allows our 19 volts through from our source pins to our drain pins. If this MOSFET is switched on, we should expect to find our 19 volts here. And then it goes through a current sense resistor. The current sense resistor, as we know, allows the system to detect and make sure there's not too much current coming onto the motherboard. It goes through that current sense resistor, out the other side, and then through these 6 vias, and that's our main power rail right there. Now, to see what's going on with this laptop motherboard, we need to inject power onto it, given that I don't have an AC to DC power adapter for this. But just before doing that, I want to do a quick check and make sure that there's no obvious shorts on the input section and in the main power rail. So let me show you how I do that now. So with all power to the board shut off completely, I introduce my multimeter in diode mode, and I place my red probe to ground, and then we can take some measurements with a black probe. So first place I want to measure is on our input section. So our voltage should come in here and through these inductors and onto these drain pins. So the first place I'm going to measure is right here. When I take a diode mode measurement here, I find there's 1.89 volts. So that's fine, there's no short at that point. The next point to measure is between these two MOSFETs right here. So where's the easiest point to measure? Well, we can measure at the source pins of the first MOSFET, and when I measure here, I find that there's a voltage drop of 1.812. So there's no short at this point. So we've no short here, and we've no short between the two MOSFETs. So the last check I want to do at this time is just to check that there's no short on the main power rail. So as we established earlier, our voltage comes in through our first MOSFET, through our second MOSFET, and this is our main power rail. So we just want to take a measurement at any point here. So the easiest point to measure is probably just after this current sense resistor. So I place my probe to the other side of the current sense resistor, and I measure 0.540. So we've no short on our main power rail either. Now that doesn't necessarily mean that there's no short further down the board, but that's just sort of a quick check just to make sure that there is no shorts on the input section. So what I'm going to do now is I'm going to use my DC power supply and inject 19 volts onto this board, and we'll see what happens. Now, just to confirm what voltage we should be injecting, I checked the back of the laptop, and that is where it tells you what voltage it takes. So we have an input of 19 volts DC, and it can draw up to 1.75 amps. Now what I'm going to do with my power supply, which I introduce here, I'm going to put 19 volts on it, but I'm just going to put a limit of 0.5 amps on it, just in case there's a short somewhere further down the board that I'm not seeing with those initial checks that I did. And we're going to connect our black wire to our ground and our red wire to where our center pin on our DC jack hits the board. Okay, so let me just zoom in on that. So with that connected, we're going to go to the real world, and I'm going to show you what happened when I did this.
This is my motherboard, and as you can see, I have connected a black wire to my ground. Whoops, black wire to ground, red wire to the center pin of the adapter. And what I'm going to do is I am going to switch on my power supply. I've set it to 19 volts, and what's happening? Oh, it's actually started pulling about 330 milliamps, and we have a light coming on. So what exactly does that mean? I don't think it should be pulling that much. I haven't even hit the power button yet. I think what I'm going to do here is I'm going to put down the camera. I'm going to touch around the board and see if I can find anything heating up. And I will let you know if I do find something heating up.
So while injecting my voltage, I touched around the board to see if I could find any component getting warm. And what I found was there was a component right up here, this UP0132P. This was getting extremely warm. So what I wanted to do then was just get my microscope, apply a bit of flux around this general area and see which component burns off the flux the quickest, because whichever one burns it off is usually the one that's carrying the current to ground and heating up. So let's do that now. I've zoomed in on that UP0132P IC, and I'm going to put a bit of flux on top of it and see what happens. Let's see. Okay, so you can see that it is being burnt off. Not super fast, but it is actually burning it off. It's burning it off faster than it is from the capacitors anyway. So I think, and even just by feel, the component that is heating up is this one right here. And this is the UP0132. So I'm going to remove this and see if that stops the excess current from coming into the circuit. This is a quick video of me removing that IC with my microscope. The board slipped underneath me, as you can see, but it came off pretty easily with a bit of hot air.
So with that IC removed, I want to inject power again. So we're going to press my DC power supply to switch it on. And as you can see, there is no longer a draw of 330 milliamps. So what I've done here is I've actually connected back in the keyboard, which contains the power button. And I'm going to press the power button right now in 3, 2, 1. Okay, so it's gone to 40 milliamps and there's no display. I just wanted to see what would happen with that IC removed, see would it still boot or would it react to the power button. It is reacting to the power button for sure, but we are not getting any display. I have the HDMI, we also have an LED on right here, but there is nothing happening. So I think we need to replace that IC in order to get this laptop back working again. Let's see if it responds when I press the power button off. So I'm going to press the power button in 3, 2, 1. So I'm going to press and hold the power button. Let's see what happens. See, there's a light going. I think that's 10 seconds. That's 10 seconds and it goes off. So it is responding to the power button, but without that IC, the laptop will not boot. So we need to replace that IC and hopefully that will get back working again.
Now, after I remove this IC, it's always good practice to check the motherboard, at the positions that it's connected to make sure there's no shorts, secondary shorts on the motherboard. So I checked here, 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 and here in diode mode, and I couldn't find any other short. So I presume that the issue is with this. The one thing that was curious was when I tried to do a check on this to find which pins were shorted on this IC, I couldn't find any that were actually shorted. However, I went online and it seems like other people on bad caps have also found this chip to go bad on some of these Asus laptops as well. You can see that there is, the first chip is second IC, looks like temperature control for me. What's he saying? Okay, it doesn't say it on that, but they're talking about replacing it with alternatives. And there was another guy with a similar Asus to what I have here, said the same thing, it was heating up and they were looking at replacing it. So I think that is what is wrong with this one. This laptop is quite old, so I'm actually not going to bother replacing it on this. And like I said before, I hate when I do videos and I don't have like a conclusive finish. But I think what you would have learned from this one would be that when you're injecting, find out what the power is required from the back of it. I showed you how to connect up the power supply to the motherboard and limit the current just in case you're curious about it. We've seen how to check for shorts before connecting the power, just for safety. And then when you see a higher current draw than what you expect, you can tap around the board and find and see what components are likely to be wrong. So I think that a lot of these laptops that I've got are the hard cases. I think somebody in another shop has looked at these, had a go and passed them on, because we're certainly not getting any easy fixes. The good news is I've bought a laptop from a young man up the road. It's not powering on, and I think it'll be better material for the channel. It's not something that somebody has possibly looked at already. So what I'm going to do is I'm going to end this video here. Please like and subscribe, and I'll be back with that other laptop at some stage next week.